We are going to do some more examples with partial fraction decomposition. We use partial fractions when we've got some sort of fraction to integrate that's not an ordinary UDU. So it's got to be a fraction that consists of polynomials. We don't need square root signs or anything in our way. It's a polynomial divided by a polynomial. When our fraction's in reduced form, our plan is to see if we can factor the denominator as much as possible. We can get our denominator completely factored. Then we have some techniques to find fractions that add together to give us that single fraction, where the simpler fractions should be easier to integrate. So all we need is remember the basic rules. We've got the linear factor rule, the quadratic factor rule, and the repeated factor rule. And I had some examples that I was working. I think I worked 2 examples last time, maybe. I don't remember. I did a linear factor and I did a repeated factor, or did I do a quadratic factor?
Oh, yeah, you told us that we
You
did
did a
a
quadratic
one.
factor as well.
And you left off on something.
You didn't finish it?
Yes, yeah, okay,
Yeah,
it
we
was,
left off halfway through.
yeah, where we are right now is 2 over.
Where did I start?
X to the fourth plus 1 over x to the fourth minus.
Oh, well, let's start that all the way from the beginning. We had to divide first, right?
Yeah.
All right, so back to the example that we were doing. X to the 4th plus 1 over x to the 4th minus 1. Bunch of markers at work, and I grabbed the one that from last time. So not only did we decide that this was not an ordinary UDU integral, it was a fraction that was not in reduced form. So we put it in reduced form by dividing this thing first. Just go ahead and divide. X to the 4th goes into x to the 4th one time. Now when I multiply both of those, and I subtract that line from the line above it, then I get a remainder of 2. So we got that this thing looks like the whole part plus the remainder over the divisor. So we go for that partial credit and go ahead and integrate the 1. Integrate the 1. And there's my marker that works better. Go ahead and compute that integral there and get x. And then over here, we're going to do the partial fraction decomposition. So we had to factor x to the 4th minus 1. So let's see, x to the 4th minus 1 was x squared minus 1 times x squared plus 1. We recognize that as being prime, but this is factorable again as x minus 1, x plus 1 times that. We write x minus 1, x plus 1, and x squared plus 1. Okay, so we're going to try to break that integrand up into separate fractions. So we've got 2 linear factors, 1 prime quadratic factor. And so let's do that part over here. And so our bet were 3 fractions that had the individual denominators. For the linear factor, we guess a constant. And for the quadratic factor, we guess linear. So we had 4 unknowns. We need to come up with 4 equations. First thing we do is get the equations by multiplying both sides by that denominator. So we're going to put all of these times this, – 'leaving us with the 2 over here. So when these three factors are written up here next to the A, the X minus ones will match and they'll cancel. Leave me with A times this. If I take this and put it up here, the X plus ones will match and cancel. Leave me B times the other two factors. And then finally, when this is up over here, the X squared plus ones cancel. So I've got the entire CX plus D multiplied by the other two factors. We get this far last time?
Yes.
Yeah,
That's
well,
where we
that-
ended.
That's where we ended up. We can multiply this out and equate coefficients. But that's gonna take a while. Or we can try to get some cheap values by making choices for X to see if we can get any of the variables. So do you see anything that we can put in for X?
-1.
-1, and then we'll do X is 1. So let's get those two equations. Let's see, I can still fit it here. So substitute X is 1 in. The left-hand side will stay at 2. When X is 1, this becomes 2 and that becomes 2. So I have A times 4. When X is 1, that's going to give me 0, so it's going to multiply out to give me 0. When X is 1, that's 0, so all of those are 0. And that'll give us A. A is going to be a half. Put that in the box so we don't lose it later. Then he said X is -1 should give us a value. Let's see, I can put it right here. X is equal to -1. The left-hand side will stay at 2. If X is -1, that's 0, so A is gone. If X is -1, this is a -2. That's a +2. So -2 times +2 is going to be a -4B. And if X is -1, the CX plus D will be multiplied by 0. So I get B that way. B is going to be a -1/2. Any other choices for X?
Not make it 0. no.
Not here.
Equals 0.
But X is 0. X is 0 is going to get rid of the C. So let's plug in 0 for X. Put it right here. So I get 2 is equal to, let's see, this is going to be 0. So 1 times 1 is 1 times A. X is 0. I get -1 times 1 is -1 times B. If X is 0, that term's gone. And D is going to be multiplied by -1, so minus D. And we have A and B. A is a half, B is -1/2. So 2 is equal to 1 minus D. So D is -1.
I'll make it a-
Is -1? Still have one variable to go find. You can do that by equating coefficients or just grabbing a number at random, generating a fourth equation. We have 3 numbers to put in for A, B, and D. We should be able to get C real quick. So let's see, how about I use a 2? X is 2. I use the easy number 0, 1, and -1. Let's go through there and put in 2 for X. I have 2 is equal to, let's see, let me start here. 4 plus 1 is 5, times 3 is 15A. X is 2, so that's going to be a 1. I get 5B, so 15A plus 5B. X is 2, so I have 2C plus D multiplied by 1 times 3. So I have 6C plus 3D plus 6C plus 3D. Now I'm gonna put all my known numbers in. A is a half, B is a -1/2. So this is gonna be 15 halves minus 5 halves. C we don't know yet. D is -1. So D times 3 gives me a -3 here. Ten halves is 5. 5 minus 3 is 2. 2 from 2 is 0. So 0 is 6C. That means C is 0. Now we're going to put that up here to integrate. We've already got the X. And we are going to try to integrate the 3 fractions as something over X minus 1, X plus 1, and X squared plus 1. A goes here. A is a half. B was -1/2. C was 0. D is -1. Anything over there that you can integrate? Every bit of it, right? The first 2 are logarithms because X minus 1 is U, du is dx, same deal here. What's this integral? Inverse tangent. So we got the X from original division plus 1/2 the natural log of X minus 1 minus 1/2 the natural log of X plus 1 minus, and since this A squared is just 1, I just have the arctangent of X. Back on the plus C, and we got it. So I'd like to do another one where you have to divide. I want to do a couple where I challenge your factoring skills. Any questions on this one? Find one where you have to divide. Kind of gives it away though, huh? When I tell you you have to divide.
Our next exam is 2 weeks from today, right?
What you have to say? Yes,
Okay. And it's on all of 7?
and all of 7,
That would be 20th.
the 20th. 20th is correct.
Please. My teacher test.
Wow.
She's gonna forget or something.
It's in the syllabus.
There's a potential thing
She
that
would
maybe,
not-
maybe later
I
on
would,
Monday.
when we finish a chapter, I start thinking about a test.
I need to remember all my
I don't remember trig
traits.
rules.
Yeah, do my flashcards.
What?
I'll just need to make some, because I don't remember my trig rules sometimes.
I make flashcards.
That's a very good idea. I'm probably gonna go do that.
I know like all my integrals and derivatives now, and I feel really smart.
I know.
Subtle clips. Okay, I guess I'm gonna make one up, so you're gonna get goofy numbers.
Just do what you did the one other time and just make one up with perfect numbers.
Yeah, just fall into it. Fall into it face first. So if I had one on here. You know, maybe we'll just leave the x to the fourth plus one up there. Let's try to integrate x to the fourth plus one divided by x squared plus 6x plus 9. So it's not in reduced form. You're going to put it in reduced form, dividing the x to the fourth plus one by the x squared plus 6x plus 9.
They give us some pretty nasty numbers.
Is it?
Yeah.
Okay. Is there anything I can do to make the numbers better?
It becomes, it's not like.
Oh, that's not.
It's just
that's
like,
not
I don't like those numbers. They
I mean, you're not getting pi raised to the e power or anything like that. That's a nasty number. Where's it go? Where's it go? Where's it go? I don't like the x squared plus 3. Because x squared plus 6x plus 9 is x plus 3 all squared, not x squared plus 3. Made it too easy. I get the same thing you guys get. Yeah. So it goes again. What do you multiply that by to get that?
Starting here.
Starting here, the x squared, you always look at the mean term. 6 as well, don't you?
Yeah.
Multiply all 3 of those terms by minus 6x and line them up. All right, subtract that line from the line above it. Six x squared? No, that's a 36, never mind. 36 minus 9 is 27, maybe 27x? Okay. Plus 27, my bad. One more time, look at the lead term.
We divide if they're even. Like if I have x squared over x squared, I divide. it
Yep,
by-
you gotta keep dividing, gotta get the degree on top lower than the degree on the bottom. Catch me up. 27 times 6. I'm glad I did it. Yeah. I 27 times 6 is 120. 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 27 times Me too. Nine times 27.
Hmm.
23. That line from the line above it. It doesn't look like what. It's getting big old chunky numbers. I did get 243 in there. You didn't get a 243 in there.
I might have done something.
Hmm,
I
I
got
better-
243.
All right, let's do this together. Just look at the lead term. I need to multiply x squared by x squared to get an x to the fourth. Now when I multiply all three of these by x squared, I get x to the fourth plus 6x cubed plus 9x squared. And then we're going to subtract that line from the line above it. So the x to the fourths are gone, and I have a minus 6x cubed minus 9x squared plus this 1. Now I look how many times x squared goes into a minus 6x cubed, and I'm going to need a minus 6x. So when I multiply, there's the minus 6x cubed. Then negative 6 times negative 6 is a negative 36 x squared. And then minus 6 times 9 is a negative 54x. Subtract that line from the line above it. So this is gone. This gives me 36 minus 9 is 27 x squared. And that gives me plus 54x. And then from the first line, plus 1. So next I've got to multiply everything by 27. And that gives me the 27x squared. 6 times 27 is 162, and that's going to be plus 162x. And then 9 times 27 was the 243. And subtract that line from the line above it. So the x squareds are gone. I need 162 minus 54. Negative 108. And then 243 minus 1 is a negative 242. And that's a lower degree. So that becomes the numerator of the fraction. So what that says is I can write this as the whole part. X squared minus 6x plus 27. We'll do that individually. Plus the remainder minus 108x minus 242 all over the divisor, which I'm now going to factor. Can you factor x squared plus 6x plus 9?
Yeah, x plus 3 squared.
X plus 3 squared. All right, if you want, you can put that minus sign out front, but I'll just leave it in there. They're both even. We could actually pull out a 2. That's, I think, the most that they might have in common. So I'm not going to pull anything out. I'm just going to deal with the big numbers. Okay, so we can get the partial credit by integrating those 3 terms over there. Now we're going to do the partial fraction decomposition on the other one. Before I move on, do you have any questions about the steps on the division? Just gotta be careful, right? You're in. Okay, so this is a repeated factor that is linear. How does it break up? X plus 3 and x plus 3 squared is our 2 separate denominators, and both of them have constants on top. So we're going to break this up. as something over x plus 3 plus another something over the x plus 3 squared. And so when I multiply both sides by x plus 3 squared, I'm left with the numerator on the left. Multiply that here, and I'll get a times x plus 3. Multiply that here, and it just gives me b. So this one's relatively easy to just equate coefficients if you want. A is the only thing that's going to be multiplied by the x. So what does A have to be?
Negative 108.
A is negative 108. This x has to be that x. So A is negative 108. Then our two constant terms, I'm going to have a 3A plus B is negative 242. 3A plus B is negative 242. Now let's substitute in our value of A. So 3 times negative 108 plus B is negative 242. So that's negative 324 plus B is negative 242. So add 324 to both sides. Here I'm doing this in my head. About 82. B is a positive 82.
That's what I got.
Hoorah. I got whole numbers again. Not great whole numbers, but by gosh, we didn't get 342 over 17.
Square root of 3 or something.
So what I'm doing to get these equations, I'm just equating coefficients. It wasn't so desirable to plug numbers in, right? I didn't want to plug in a -3, but eventually I did. So the coefficient of x was the coefficient of x, the constant was equal to the constants.
Can you show me you got 3A plus B right quick?
Just-
If I multiply out the right side,
Yeah, A.
that says ax plus 3a plus b. So there's the coefficient of x,
Okay.
there's the constant term. So x equals the x, the constant equals the constant. Okay, so that means that we do this integral as a negative 108 over x plus 3, and this one as 82 over x plus 3 squared. So let me go ahead and integrate here. In that first batch, I have x cubed over 3 minus, let's see, x squared over 2. 2 cancels. How about 3x squared plus 27x plus the integral of a, which is a negative 108 over x plus 3. And then plus the integral of b, 82 over x plus 3 squared. How do you do those two integrals?
The first one's just natural log.
Okay,
And then the second one's gonna
Yeah, you
be
do.
negative 82 over x plus 3.
okay, so we're integrating here a u to the -2 du with the 82 out front. U is x plus 2, du is dx. When we add 1 to the exponent, we get u to the -1 over -1 times the 82. So we get negative 82 over u, or negative 82 over x plus 3. So our final answer, I'll write it above it. X cubed over 3, oh, stretch, minus 3x squared plus 27x minus 108 times the natural log of the absolute value of x plus 3. Then we said this was minus 82 over x plus 3 squared.
It's not squared.
It's not squared.
Not squared, it's just itself.
X plus 3.
Yep,
Oh,
yep,
yeah, we got it.
you. Thank you. That'd be a bummer to get it right all the way here and then write it wrong right there.
That in Webber.
Now I know how you feel. I just don't get the big red band. I just have everybody hollering at me. Ready for another one? I'm gonna make it up. I can't guarantee pretty numbers.
I believe in you.
You believe in me?
I
You're
think
2
we-
for 2 so far.
Yeah, I think we can go 3 for 3.
There's no way I'm gonna get this
Third
one.
time's a charm.
Yeah.
No way I'm gonna get this one.
Yeah.
That's right. We are gonna have some fractions that you're not gonna like. All right. Let's,
How about 1/1 dx?
I know that. How about 3x plus 5 over x cubed plus 8? Tell me why that's a candidate for partial fractions as opposed to other techniques we have.
Yeah.
No.
It's not a UDU, right? U is x cubed plus 8, du is 3x squared. Oh, you can't do a UDU. Then have square roots, so we don't want to stick trig functions in there. Plus, it's got a third degree. We don't want to take trig functions to a third degree. Other techniques. So we're kind of stuck. But partial fractions is for things that we can factor. Do you know how to factor x cubed plus 8? Or is it prime?
I think.
Yeah, it
I'm
is.
pretty sure you
But I
can.
forgot how.
But you forgot how.
Isn't it like x plus 2?
There's probably a factor of x plus 2, or maybe there's a factor of x minus 2. One of those is a factor.
No, I got it.
Can you tell me something that makes x cubed plus 8 equal to 0?
Oh, wait.
When is x cubed plus 8 equal to 0?
There too.
When x is negative 2. So x is equal to negative 2 is a 0, which makes x minus negative 2 a factor. Right? Do you know the factor theorem? You know a 0, you know a factor? Since x is equal to negative 2 is a 0 of x cubed plus 8, that means x, move that over, plus 2 is a factor of x cubed plus 8.
Thank God for college.
If you know one factor, you can find the other factor just by dividing. So you can find the other factor by long division, or who remembers synthetic division?
What if we do this? I got a trick.
You got a trick.
I do. So what you do is you take the cube of each one. So we have x plus 2, that gives us our factor,
Okay,
right? And then what you do is you have the first one, the first squared. So you have x squared. And then you have the multiple of the 2, and I don't remember if you multiply by 2. I don't think you do. But that sign is opposite. So now we have x squared minus 2 or 4x. I have to multiply it out.
okay.
And then your last sign is always positive, so it's plus, and it's the last square. That's the last thing squared.
Okay. I'm gonna do synthetic division, so I don't have to memorize anything.
I think I got
I
it.
bet you're right, because there is a formula, but I know 2 formulas in my whole life. And I get them confused with each other. So I'm gonna go ahead and do synthetic division. So if x is equal to negative 2 is a 0, I put a negative 2 out here. Then I put the coefficients of this polynomial. in descending order, and I've got to have each variable represented. So I have a 1x cubed, let's get up there. I need a line here. 1x cubed, 0x squared, 0x plus 8. And then we bring this first term down, multiply and add. Multiply and add, multiply and add. This is what's telling me I have a factor. And there's our other factor. That's exactly what you told me, isn't it?
Yes.
This is 1x squared minus 2x plus 4 is the other factor. So I have an x plus 2, 1x squared minus 2x plus 4 here. Does x squared minus 2x plus 4 factor? It's prime, isn't it? There are no factors of 4, both with a minus sign that add to minus 2. So that's a prime quadratic factor. So we're going to do our partial fraction decomposition now with a linear factor and a prime quadratic factor.
So when it's prime, it never touches the x-axis.
Right. Or if it does, it doesn't do it in any place that we want to factor it. I don't want any eyes. All right, so let's break that up. All right. So we got 3x, let me move that up just a little bit. 3x plus 5 over x plus 2, x squared minus 2x plus 4 is equal to a over x plus 2. And then my other one's a quadratic factor. So we need a bx plus c. Now we're going to multiply both sides by the denominator on the left, which leaves us 3x plus 5 on the left. And when I take that up here, the x plus 2's cancel underneath the a, and a will be multiplied by x squared minus 2x plus 4. And then the bx plus c will be multiplied by x plus 2. Okay. Now that 5 may or may not stay there. I might change it depending on what we get for A. How am I going to get A real quick?
Plug in -2. X equals -2.
X is equal to -2. Let's not worry about the 5 just that. Let's see what happens if X is -2. That's going to be multiplied by 0, so BX and C are going to be multiplied by 0. -2 squared is 4. -2 times -2 is another 4, so I'm at 8. And now that's at 12. So 12A. Let's replace that side. I don't want A as 112. So let's see if we can get something nicer here. Let's see, that's a -6. How about I change that 5 to a -6?
I'm already almost done solving it. I'm about to find the last one.
Well, as soon as you are for jumping ahead of me, right? So then that gives me negative, so let's make this a -6. Because that didn't show up anywhere yet. 3x minus 6. Make a new problem.
You're just making new progress.
I made a new problem. Just so I get a nice whole number for A and cross my fingers that all the other ones be whole numbers. So if X is -2, I have -6, -6 gives me a -12 over here. So A is -1. That's the only reason I changed it. So I can get A as -1. And it never showed up in this calculation. And so make all the +5s into a -6.
Right, there's nothing you can do to A to make it 0 because it doesn't have any zeros. So you
How
have
about X is 0?
to- Yeah, you have to change X to 0.
All right, let's change X to 0 to get rid of the B. Okay, so the left-hand side becomes -6. 0 here, 0 here gives me +4A on the right. 0 here wipes out the B. 0 here gives me +2C. We have A is -1. So that's a -4 on the right-hand side. I'll move it over as a +4 to the left-hand side. So I get -2 is 2C. So -1 is C.
Golly, maybe the third time is not the charm.
Well, I had to cheat. So I'm not gonna take all the credit for that.
I think you should take the credit.
Okay, and now I don't have any magic numbers, so pick your favorite number and plug it in for X. 1, let's use 1. One on the left side gives me a -3. Let's see, 1 minus 2 is a -1, plus 4 is 3 times A. B plus C is going to be multiplied by 3. So plus 3B plus 3C.
Interesting.
And A was -1. B is what we're looking for. C was -1. Looks like B has to be 1.
Wow.
Catch our breath right there. Then we got to go look at what we're going to integrate. We are going to integrate A over X plus 2. So -1 over X plus 2. Now BX plus C. B is 1, C is -1. So 1X minus 1, or X minus 1 over X squared minus 2X plus 4. I made such an awesome problem.
that's beautiful.
That is an awesome problem.
Write that down.
I know, write it down for next semester. Why was that such a good deal?
UDU.
That's straight UDU right here. Right? If U is the denominator, I get 2X minus 2. Divide both sides by 2 and I get an X minus 1 times DX. So that's UDU. What if it wasn't?
You just cry. and give
What
up.
if this wasn't an X minus
X squared
1?
minus 2x plus 5.
Say it again. But what if it wasn't UDU? How would you integrate something over X squared minus, like, how would you integrate, take the X away? What if our V turned out to be 0? No, because the degree is lower.
Factor.
Doesn't factor, it's prime, remember? Complete the square, thank you. Complete the square, complete the square. Okay? All right, and then it would be an inverse tangent. But that's a UDU. We're gonna take U to be X squared minus 2X plus 4. DU is 2X minus 2 DX. So 1/2 DU is X minus 1 DX. So the first one's a logarithm minus the natural log of X plus 2. The next one is going to have a 1/2 integral. That's a logarithm as well. And so I have minus the natural log of X plus 2 plus 1/2 the natural log of u, but u was x squared minus 2x plus 4. What do you think? You need more paper.
You only got, have you not gone through like a whole notebook yet?
I'm almost through both of mine.
I had to take out all my notes from my binder, it was too full. I have a stack in my drawers about this. Yeah.
Okay,
This is why working horizontally is superior.
so let's think about the integration techniques that we learned. And 7.1 is refresh our memories. But some of the memories we needed, other than basic UDU, was we had where we could do an integral, maybe split up the numerator, make 2 simple integrals. We had our regular substitution and a double substitution.
Didn't we also? Oh wait, no, that was those two.
We had completing the square also as a refresher there. And then we went to 7.2 and we used integration by parts on integrals, which were products of polynomial terms with trig, log, exponential functions. We had integrals of inverse trig functions, and we had integrals of logarithms. Those were all integration by parts kind of things. Some of the things that we did with a double substitution, we maybe could do with an integration by parts. Then what did? We did trig integrals, and we did integrals with trig substitutions. Then we did polynomial integrals by partial fractions. So in section 7.5, it's, here they are all mixed up. Ooh, tell me what you think.
Gross.
So I'm gonna put one up here, and you're gonna tell me what you think. And I got a whole list of them. Try.
So what you're saying is now we're getting to the point where it's a full page per problem.
I mean, it's
No.
already a full board for problems.
Right, you knew partial fractions was partial fractions because it was sticking right there in the section called partial fractions.
Section 7.5 is the monster. Why do you have an example on that?
There's an example for you.
So the title of 7.5 would be like everything.
Everything, review of all integration techniques.
The little thing that says example looks like could be part of the problem. I'm sick. You can't blame her.
Basic history of everything.
And I've skipped some integration techniques. There's another substitution called a Weierstrass substitution. And I think I lived most of my life without it. I'll let you live yours without it. But I had to do it when I was a student.
Is that Cal 3 talk or?
No, it's just another integration technique. Sometimes you just say the heck with it and you look it up in the table.
My favorite table is Google.
I always like integration because it's like puzzles. I like doing puzzles, riddles. I like things that have steps. All right. Let's see, e's in my integral, I try UDU. Does UDU work?
Right, it does.
Yeah.
Hey,
So
Okay, tell me what I do.
it's u squared minus 1 d
Okay.
over.
So we're gonna let u be e to the x. du is e to the x dx. And does that bother you in any way, shape, or form?
No.
Because how's e to the 2x related to e to the x?
It's u squared.
So u squared is the same as e to the 2x. So this integral becomes e to the x dx is just a du. And this interval becomes u squared minus 1.
Some kind of an inverse trig function. I'm still working on it.
You would go with an inverse trig function on
I would
that.
do the natural log.
Or a natural log.
Oh, wait, no, I can't.
It's some sort of trig.
You want to do a trig sub? That's nailing an attack with a hammer.
Isn't it? Well, is there some like?
Double
By
substitution.
parts, the fraction by parts.
What do you mean?
Like you can split up the u squared minus 1,
As?
u minus 1, u plus 1.
Yeah, it's just telling, this hollering out to factor, right? Can't hear it? No, it has to holler louder.
Partially deaf.
Well, this is gonna be partial fractions.
You should have known, I guess.
Right? Isn't that quicker than trig substitution? I'm not saying trig substitution won't work, but trig substitution is for pesky radicals. I don't see no radicals there. Right? So do the partial fraction decomposition on this. Find out how this breaks up and how does it break up? Something over u minus 1 plus a something over u plus 1. Right? And both of those would be constants. Let's see if you can find those constants real quick.
A equals -1/2 and B equals 1/2.
I agree. If you can get A is -1/2 and B is 1/2. A is 1/2, B is -1/2. Yes? And so we're integrating here. A over u minus 1, A was 1/2. And B over u plus 1, B was -1/2. And since that's just 1 u to the first power, those are both logarithms. So we get 1/2 the natural log of u minus 1 minus 1/2 the natural log of u plus 1. Each u is e to the x. Okay. So after a substitution, we get a new integral, but then we'd have to do that new integral with our new technique. Okay, so maybe something like this. Does this make you think of anything?
By parts.
Integration by parts. When that's next.
You gotta change it to 1 minus cosine 2x over 2. Wait, is that right? No, that's not right.
No, we
Because
just,
that's for a sine squared.
how about,
You could do a u substitution.
that's what I was gonna do. U equals
We're gonna
X
do a
squared.
substitution, but I kind of thinking I'm gonna do integration by parts beyond this.
Yeah.
So I'm gonna choose a different letter than U.
W.
W.
Okay.
What's W gonna be?
X squared.
W is gonna be x squared. So dW is 2x dx. So I'm gonna have to borrow an x from here, right? I'm gonna think of that as x squared times x. I'm gonna write the x out on the other end. So now if I get this 2 out of the way with the 1/2 dW,
What now? Use sine U.
we got no u's yet, we got
Oh,
w's.
sorry, W, sorry.
So that's a W, that's a sine of W, and that's gonna be my 1/2 dW. So here's the 1/2 W, sine of W, dW. Now it's integration by parts. Okay? Couldn't do integration by parts here because I don't know how to integrate sine of x squared, but I do know how to integrate the sine of W. Could have also done integration by parts here, I guess, had I let u be x squared and dv be x sine of x squared. That would have worked. Then we could have done that. You know what I'm saying? I think this will work fine. And now we're going to do integration by parts. I need a u and a dv. Which one's which?
Use the side, right?
Which one's W? U is W.
Oh, yeah.
dv is sine of W dW. We want to get a lower degree polynomial. So du is dW. What's the integral of a sine?
Negative cosine.
Negative cosine. And so that integral with the 1/2 here becomes uv minus W cosine of W minus the integral of V, but V itself has a minus, I'm gonna make that a plus, cosine of W dW. And we can do that. Integral cosine is a sine. So we have 1/2 times the quantity minus W cosine of W plus the sine of W. And then let's finally replace each W with x squared. And so our final answer is minus 1/2. Oops, I want the minus 1/2, just 1/2 x squared cosine of x squared plus the sine of x squared. Okay. Now I got 22 integrals for you. Some are easy.
It's like a pop quiz.
Oh, that'd be kind of fun, wouldn't it?
I'm sorry.
Yes.
I'm sorry, everyone.
I want to see how many of these you can get done in 15 minutes. What I want you to do is sniff out the easy ones first. I want to see if you recognize easy when you see easy.
Is this one open note?
Oh, yeah, it's teamwork, everything.
Oh,
I want to see when you recognize easy. You know,
Got that one.
you can recognize easy when you're hanging out in the club. So why can't you recognize easy when you're doing calculus? I can't get that up.
I'm gonna write my.
oh, yeah, we need it.
And I actually have these all worked out on Blackboard, but don't pee. That makes it really easy. I can't get these apart. I don't want to lick my fingers. That's two of them. Can't get it apart either. You get to do them twice. So you know, when you were in elementary school and you did multiplication tables to time,
Yes.
we're gonna do this to time. I
That
wanna
was
see
close.
who can get the most in 15 minutes. So find the easy ones. It's a competition. The winner gets $25.
How much are you joking about?
Oh, I have absolutely no money on me. And I don't think it's legal for me to give you money for giving answers. So you trying to get me fired, huh?
No.
I can do that all by myself.
I feel like you can do it a lot easier than you think it.
I know. Somebody told me the other day, somebody made a real disparaging comment about me on one of these chat boards online. Why would they do that? Some biscuit. He gives biscuit behind next to my CEO. Some of these, I hope, just pop right out to you. Rags here with my pants. One good thing about the pandemic, we now have things to wash our hands with in the classroom. There might be like 8 or so that are just regular old whip them out intervals. Since there's nothing but silence here, I think I'm going to just shut off the recording. We'll do next time.